Okay, we're on the calculators allowed page. We've got a problem where $2,350 is invested at 7% interest for 10 years. We just solved that by plugging it in. Oh, it's also compounded monthly. I didn't write that, but compounded 12 times a year. All right. So the equation then is that the amount we have is going to be based on the principal, 2,350 times 1 plus our rate, which in decimal form is 0.07, and we're breaking that up into 12 bits because we're checking on it 12 times a year. So then up here in the exponent we have to do that 12 times each year times the 10 years it's invested. When you plug that all in very carefully on your calculator, it'll look something like this: 2350, then parentheses 1 plus 0.07 slash 12, close parentheses, caret, parentheses, and you can, I hope, do that math, 120, close parentheses. You're going to get this equal to, when I round it, $4,722.70. Check that out, okay? Then the next equation, that's this one here, is if it's growing continuously, we use this equation, and this is our principal, there's our E, and the rate is 0.07, and it's not 1.07, it's just the rate times 10, so it just becomes 2350 and then e to the 0.7, and this will give us an answer of 4,732 and then 32 cents. All right, and that's in dollars, of course. So you can see by having it grow continuously, we get an extra $10 over 10 years. It's not much, but it's something, especially if it's in billions of dollars. All right, so first answer, second answer. This one now asks, if you know it's going to grow to $10,000, how long does it take? Now we need to solve for x. All right, and hopefully you thought about that and you realize the only way to solve for that is either to graph it and look at the intersection point with that line. That's a totally legit way to do it, or to use our logs to solve it. So I'm going to do that. I'm going to divide both sides by 2,350, and then when I do that I get e by itself. All right, so when I've got e by itself, I get e to the 0.07x, which we're looking for, is equal to 10,000 over 2350. Well, then I just take the log of both sides, the ln of both sides, and then that cancels, and we're left with just this being equal to the log of this. And I divide both sides by 0.07. So x then is equal to the ln of 10,000 divided by 2350, that whole thing divided by 0.07, and you'll see it's about 20.7 years. So just say approximately 20 years and maybe 7 months. But I'm not going to fault you for how you express that, decimal or months or days or minutes, I don't care. All right? Then the final one is going to be, if this money had been already invested for 5 years before it got to that amount, what was the original amount? And we're just putting in -5 because it's 5 years before. That's a pretty straightforward problem, checking to see if you know that. When you plug that all in and hit enter in your calculator, make sure those are grouped, you're going to get an original investment of about $1,656.02. Okay, so that's that. Okay, we're in the home stretch. We got some simple solving using logarithms. Again, this is the major thrust of this chapter, that we've got a way of solving for a variable up in the exponent. That's 10. That's handy because we know log base 10. We'll do that real quick. That'll come out front. We take the log of this side. X is just equal to the log of this. And when you round carefully to 3 decimal places, it's 4.995. 3 decimal places, sorry. All right. This one is similar. It's got the extra little wrinkle up above, but I take the natural log of both sides. All right. And when this comes out front and these cancel, I get x minus 3 equals the log of this, so I just add 3 to both sides and add 3, and add 3, and that is my answer, which is approximately 12.079, I believe. All right. And if you have problems typing into your calculator, just come and find me. But it's PEMDAS rules, and just be careful. So again, we're peeling away layers to get to that. All right. Start with the outermost layer, or work from the inside out. That's 2 is the closest, and then the 10, and then the 3, and then the 12 is the outermost layer. So I subtract 12, and then I get 3 times 10 to the x plus 2, and that's 45,660. And then I'm going to divide both sides by 3. 10 to the x plus 2 equals 45,660 over 3. And then I take the log of both sides of that, and that of course comes out front, and that disappears. And then I get x is equal to this whole mess, log of 45,660 over 3, and then that's minus 2. And that is the exact answer, and the approximate answer is 2.182. All right. Finally, same thing. It's made harder by the fact that this is not a handy base. 7 is not on our calculator. So I, again, peel away the layers. That is the innermost, and this is the outermost. So I take away 20. And when I do that, I get 3 times 7 to the 4x minus 3 equals 7830. And then again, I divide by 3. 7 to the 4x minus 3 power is equal to 7830 divided by 3. So now I can take the log, either the common log, base 10, or the natural log. I'll use ln, and I'm getting closer because this goes out front. This does not disappear, but I can divide both sides by this. So I get 4x minus 3 is equal to this mess, ln of 7830 over 3, the whole thing over the ln of 7, and then I just add 3 and divide the whole thing by 4. All right. Now that is a big ugly mess, but when you do it in your calculator, type in this, hit enter, divide by log of 7, hit enter, plus the 3, hit enter, and divide by 4 and hit enter, and you will get x as approximately equal to 1.761. All right, and there you go. Test is over.